Okay, let me give you a quick little lesson on conversion factors and dimensional analysis. All right, so conversion factors are a way to switch basically units on something. Like if I have a measurement and it's in feet, but I need to switch it over to meters or centimeters or something, a conversion factor will allow me to do that. So what is a conversion factor? Well, it's just a ratio. It's really just a fraction, right? So it's a blah, blah, blah. It's a ratio of two equal quantities that have different units. All right, so 1 inch is exactly 2.54 centimeters. 1 foot is 12 inches. 3 feet is a yard. All those things are conversion factors. All right, but if I have a fraction where the numerator and the denominator are the same thing, right? Anything divided by itself is 1. So this conversion factor really, at its guts, is just the number 1, right? And anything multiplied by 1 is anything. So it's not changing anything other than the units. So I can go from roses to dozens of roses, right? Using 12, right? I can go from quarters to dollars by knowing that 4 quarters is a dollar, right? So 4 quarters is $1. So I can set up all these different conversion factors. I can say, okay, 4 quarters over $1, or $1 over 4 quarters, or 1 quarter is the same thing as $0.25. That's fine, right? So to convert something from one unit to another unit, I just multiply by the appropriate conversion factor. So which one's the appropriate conversion factor? It's the one that gets rid of the units you're in and switches you over to the units you want. So you want the given units to always be in the bottom of the conversion factor. So if I wanted to convert, let's say I had 500 quarters and I want to figure out how many dollars that was, right? The only one that has quarters in the denominator would be this one. So I take my 500 quarters and I'd multiply it by $1 over 4 quarters. All right, that would switch me to dollars. So always make sure that the unit you're getting rid of is on the bottom of your conversion factor and you'll be fine. So if you want to convert inches into centimeters, right, the conversion factor, I know there's 2.54 centimeters is the same thing as 1 inch. So I could either have inches over centimeters or centimeters over inches. Which one will I use? Because I'm getting rid of inches, right, I want to make sure inches are on the bottom of the conversion factor, because when I multiply 8.5 inches times 2.54 centimeters per 1 inch, the inches cancel, right? That switches me into centimeters, right? Because the centimeters are left over. So you just do 8.5 times 2.54 divided by 1, boop, gives you 21.6 centimeters. Done. And so that's really what dimensional analysis is. You're looking at the units. So let's say you're like really bad at algebra and like you're always dividing when you should be multiplying and multiplying when you should be dividing. You're like kind of lost. This may help you a little bit. If you just look at what the units are, it can help you. So if I have milliliters, right, if I'm given a volume in milliliters, and the question is, asking about grams and stuff, but it also gives you the density, right? Density is grams per milliliter. If you just write this on a piece of paper, like milliliters times grams per milliliters, the milliliters cancel. It'll give you grams. And if I take grams and divide that by grams per milliliter, that'll give me milliliters, right? Then the grams cancel out when you do that. So use the actual units on the problem to help you figure out like what to do with them. Like, should I multiply these? Should I divide them? That's what dimensional analysis really is. So there's all sorts of conversion factors, right? You can go from pounds to grams, knowing that there's 453.6 grams equals 1 pound. 2.2 pounds is a kilogram. It's another handy one I use all the time. Meters to inches, right? You can convert meters to centimeters by knowing that 1 centimeter is the same thing as 1/100th of a meter, and I go convert centimeters to inches because 2.54 centimeters equals 1 inch exactly. Some of these things get crazy. All right, some of these conversions, they'll have a big old long string of things. Right? If I'm given a speed, it's in meters per second, and I want to switch that over to America units, I want to go, what's that in miles per hour? Because my brain doesn't think meters per second. Right? You can multiply meters per second by 1 kilometer is the same thing as 1,000 meters. That'll give you kilometers per second, and then we can switch kilometers to miles using this conversion factor. We have miles per second. We can switch that to miles per minute using this, and then if I multiply miles per minute by this conversion factor, right? There's 60 minutes in an hour. We'll get miles per hour. So normally we don't do these things up and down. I do them side to side. So for an example, let's say we're trying to figure out like 10 million inches per day. Like that's a speed. It's how fast it's going. But what is that in miles per hour? Like, is that really fast? Is it actually really slow? Or is it somewhere in between? Is it something you can do on foot? Let's see, how would we do that? So I need to convert inches into miles, and I need to convert days into hours. The order you do that in doesn't really matter. So I should do it this way, right? So I have 10 million inches per day. I start with the inches first. So because inches on top, I want inches on bottom. I know there's 12 inches in 1 foot. And then since feet are on top, I want feet on the bottom. I know there's 5,280 feet equals 1 mile. All right, so that's good. So that'll give me miles on top. And the last one here, I want to switch days into hours. I know that 1 day, so since day is on the bottom here, day is on the top of my conversion factor. And I know there's 24 hours in 1 day. So when you run through here, like when you're actually doing this on a calculator, take the number you're given, multiply by the top number, divide by this, times this one, divide by that, times divide. So I'm just zigzagging down this whole choo-choo train as I do that. These are all kind of weird because the numerators on all these are 1. But that's not always going to be the case. You're going to see some stuff later on in this course where they will be 2 different numbers, and 1 is not going to be one of the numbers. So just kind of get used to that pattern. Multiply, divide, multiply, divide, multiply, and divide as you zigzag your way through here. But when we do that, we come up with 7 miles per hour. So 10 million inches per day is only about 7 miles per hour, which is not too crazy fast. That's that. All right. Catch you in the next video.